So each translation rotational degree of freedom of a molecule is half kBt of energy. Okay. For example, so we talked about monoatomic gases. उसका डिग्री ऑफ फ्रीडम कितना होता है, याद है, बताया था ना? In how many ways it can have energy? It was 3, correct. So F is called degree of freedom. Okay, F is called degree of freedom. Degree of freedom monatomic is 3, diatomic it was 5. Very good, 5, because it was 3 translation plus 2 rotational. Okay, ये दो ही इंपॉर्टेंट है, ठीक है, और बाकी ट्रायटॉमिक भी होता है, बट वो इंपॉर्टेंट नहीं है बिकॉज इट इज नॉट आस्क्ड. ओके, ठीक है. ओके, नाउ so the second formula is that U, the internal energy of a gas of a mole. So right, to what is the, for a, let's talk of a monoatomic gas. Monatomic gas like a helium. Okay, helium is a monatomic gas, so it has 3 degrees of freedom. Therefore the and each degree of freedom contributes to half kBt of energy per molecule. So this picture, this half kBt is for a single molecule. Okay, for a single molecule, single entity. If I ask you what is the energy for 1 mole, you will multiply this number with Avogadro number, right? So for 1 mole the energy will be half kBt into R. And now what is kb into R? kb into Na. kb into Na is R, yes or no? So it is half RT. Yes. Sorry, is someone asking something? Okay. Now, so a monoatomic will have 3/2 RT, yes or no? Because it has 3 degrees of freedom, right? So this is 3 times 1 mole of, so 1 mole of monoatomic gas has U is equal to 3/2 RT. समझ में आया ये? हाँ, हेलो, समझ में आ गया कि नहीं? हाँ, okay. Now there are some terms which are called Cp and Cv, which you will understand after we are done with the thermodynamics chapter, which you are not done. Okay, ठीक है. तो Cv जो होता है वो होता है du by dt, du by dt, और Cp होता है dq by dt. ये होता है, ठीक. अब और एक फॉर्मूला और होता है Cp इज इक्वल टू Cv प्लस आर. ये भी फॉर्मूले हैं, ठीक है सारे. क्या फॉर्मूला है? Cp इज इक्वल टू Cv प्लस आर. ये भी फॉर्मूला है, ठीक है. ये भी हम पढ़ेंगे इन थर्मोडायनेमिक्स, ठीक. So Cv कितना हुआ? What is the differentiation of this thing with respect to temperature? It is 3/2 R, yes or no? If U is 3/2 RT and I'm asking du by dt, that will be 3/2 R only. Yes, yes or no? And because if Cp is Cv plus R, then what is Cp? Cp is 5/2 R. Understood? Because 3/2 R plus R is 5/2 R. Understood? So for a monoatomic gas, these two values are important. What is Cv? It is 3/2 R. What is Cp? It is 5/2 R. What is the meaning of the Cv? C मतलब होता है specific heat. Specific heat. और सबस्क्रिप्ट V का मतलब होता है at constant volume. अगर सबस्क्रिप्ट is P, then इसका मतलब है at constant pressure. Okay. So how do I write Cp as? I read Cp as specific heat at constant pressure. What is Cv? Specific heat at constant volume. Understood? So Arpita, tell me what have you, like slowly give me a recap of this. Whatever you understood, you recap.
So I understood the heat Cp and Cv part, but I don't understand the one KBT. I don't know what that is.
Netra, you do it.
So KB is the Boltzmann constant, which is the R divided by Avogadro number or gas constant by Avogadro number. So basically, for each um freedom, which is each type of movement like translation or rotational, um, one molecule will give half kBt energy. So for monoatomic gases, it's the freedom of rotation, freedom of degree of freedom is 3, which is there are 3 types of translational movements. For diatomic molecules, it's 5 because they have 3 translational and 2 rotational. So accordingly, we can multiply. And for one molecule, if it's half kBt, then to find for 1 mole, it's half kBt into Avogadro number. But since kb into Avogadro number is R, it's also equal to half RT. And we can find U from that, which is half RT into the degree of freedom. And CV, which is the specific heat for a constant volume, is du by dt. So it's 3 by 2 R for a monatomic gas, and CP is specific heat at constant pressure, which is dq by dt, which is 5 by 2 R for monatomic gas.
Okay. Good. Now, for what will be the same values for a diatomic gas? You can do it, I think now, right? Diatomic. बताओ इसका जो ये होगा मतलब टोटल डिग्री यू कितना होगा यू फॉर अ डायटोमिक
5 by 2 RT.
5/2 RT सीवी कितना होगा
5 by 2 R.
5/2 सीपी कितना होगा
7 by 2.
करेक्ट ठीक है एवरीवन हैज अंडरस्टूड टिल हियर ठीक है बच्चों okay so there is one more quantity which is called gamma is called uh, there is something it is called something coefficient adiabatic coefficient but gamma is actually cp by cv ratio gamma is cp by cv ratio so how much is gamma for a monatomic gamma for monatomic कितना है बताओ बच्चों
5 by 3.
5/3 and gamma for diatomic
7 by 5.
7/5 ठीक है very good ठीक है everyone has understood till here okay this right again gamma for mono is 5/3 gamma for di is 7/5 okay now you got to make a table in which you are writing gas then you're writing f mono how many degrees of freedom then you got to write u then you got to write cv then you write cp and then you write gamma okay this table you have to fill for two things which are monoatomic and diatomic okay so just as a revision we are filling it so abita nahi arpita tell me the for the mono values monoatomic the row for the mono
So, except for the gas for freedom, the U is 3 by 2, CV is
3/2 rt
3 by 2 RT.
what is f
So I don't know for F, I still didn't
3
understand.
degree of freedom is 3
Okay.
hmm.
CV is 3 by 2 by R, 3 by 2 R, and CP is 5 by 2 R, and R is
gamma
5 by 3.
it is called gamma
Omega, sorry. Gamma, sorry.
gamma is 5/3 yes arpita I mean you only dia
The freedom is 5 Then it's the U is 5 by 2 RT, CV is 5 by 2 R, CP is 7 by 2 R, and gamma is 7 by 5.
Good. So there is a section for polyatomic also. You have to do it as homework. Okay. There's just some definitions there. Okay. 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 Now लाया था नहीं कहीं भी उस रूम में भी हो सकती है खोल ले for a solid. Okay. See, the gases has 3 degrees. So I told you about monatomic gases. Monatomic gases will have 3 degrees of freedom because they can move in x, y, and z. Okay, right? And परीक्षा अपना फोन जरा विंडो पे रख दीजिए, विंडो सिल पे रख दीजिए फोन. ठीक है परीक्षा, keep your phone on the window sill. Window sill. X, Y, Z. Okay. So a molecule, gas molecule, a monatomic gas molecule can travel in X or Y or Z. Okay. A diatomic gas molecule can either travel in X, Y, or Z, or it can also rotate about either this axis or this axis, and that's why it has 5 degrees of freedom. Okay, right? If you see read the polyatomic section, usme there are also some vibration modes. Okay, so there in different polyatomic gases there are different vibration modes. But what happens in solids? In solid, the structure is so rigid. Everything is in fixed place. So neither translation energy is there. Translation matlab there is no motion in x, y. Molecule cannot run in x direction, right? Because it is fixed at one place. So there is no translation. It can also not rotate about its own axis. So there is no rotational also. But it has 3 degrees of freedom, vibration freedom. Vibration matlab whatever is the molecule, it can either vibrate like this or like this or like this. Okay. So in general, a solid will have 3 degrees of freedom in its motion of oscillate in vibration. ठीक है और तुमको दिखा देता हूँ ये देखो this is the part, just read this. Okay, and write this, write the key points from here. Specific heat capacity of solids. Guys, you have written. Hello? Talk, have you written? Have you written the concept here, whatever is the concept?
Yes, sir.
Yes. No. Okay, yes. Okay. Now, mean free path. देखो mean free path क्या होता है? So, mean free path means, see, in a gas container, all the gas molecules are constantly hitting each other, right? Okay, so they are in random motion, and because of that random motion, a particle will go like this does a Brownian motion, and it hits many particles whenever it is going. Okay, mean free path is, so let's say between any two successive collisions. So you're looking at one molecule, okay, and then between it is colliding with, so let's say it collides with another molecule, and then it goes on and collides another molecule. Okay, so between these two successive collisions, what is the time taken? The time is called the relaxation time. Understood? Why is it called relaxation time? Because of course for that time it was relaxed, it was not colliding with anything else, right? So between two successive collisions, the time is called relaxation time, and the distance which this molecule covers is called mean free path. Okay, understood? Okay. So we are trying to get an idea of how much is mean free path and how much is, like, what is the uh, uh, relaxation time. Okay, first free path. Write this definition. Mean free path is the average distance. Mean free path is the average distance a moving particle travels before it collides with another particle. Okay. Mean free path is the average distance a moving particle travels before it collides with another particle. Okay. Relaxation time होता है 1 second. Okay. Relaxation time is the average time between collisions of gas molecules. Yeah, relaxation time is the average time between collisions of gas molecules. Okay. Now let us write the derivation. Guys, do you remember, did I have a KTG PDF here or not? Like in my tablet, what did I have a KTG PDF or not? Okay. Okay. So Make this molecule, its diameter is d, okay? Its diameter is d, and let's say it was trying to go in this direction. And its speed is, average speed is v, so it is going with a speed which is v. So this symbol is is used to denote average, okay? So if v is the speed, then bar v, I will call it bar v, is the average speed, okay? Fine. So what is this? This means average speed. So it is going with some average speed which is v, bar v, okay? And okay, now in time delta t, it will cover a distance which is, the distance it covers is bar v delta t. Yes? Understood? Now, if, okay. Now see, if you have another molecule, same identical molecule, which is here, right? It will not collide with this, right? So because the trajectory of this path is this, it is going in this cylinder. And if the molecule is here, it will not collide with this molecule. So molecule 1 will not collide with molecule 2, right? But if your molecule 2 is on the periphery of this, right? It is just colliding, yes or no? Yes. Okay. So therefore, where must not be, like ये molecule है, what do we say is in okay, so it in time delta t, the molecule 1 sweeps a volume in time delta t, 1 sweeps a volume of, do you understand, pi d square into v delta t. Now why is this? So देखो इसका ना रेडियस नहीं लिया है, ये रेडियस नहीं लिया है, रेडियस इसको लिया है d. Why? देखो, if it is free path means 2 is not coming and touching the 1. Therefore the distance of 2, ये जो distance है ना, ये मॉलिक्यूल का डायमीटर होना चाहिए. अगर दोनों मॉलिक्यूल का रेडियस मतलब डायमीटर dd है, राइट? तो फिर ये जो 2 है, इसका सेंटर से इसका सेंटर का लाइन, this distance should be more than d, yes or no, for them to not collide. Yes. So मैंने बोला मीन फ्री पाथ है. मीन फ्री पाथ मतलब कि आई एम ऑलरेडी assuming it is not colliding with anything, right? So therefore this 2, ये जो मॉलिक्यूल है, ये इससे और पास में नहीं हो सकता. मतलब इसका सेंटर और इसका सेंटर लाइन, do you understand, this distance should be more than d, more than equal to d. Yes, that's why this much volume it will cover. I'm not saying, I'll repeat, I'm not saying that the volume covered is this, the green one. In fact, I'm saying the volume covered is by this free molecule is this much, which is shaded in pink. Understood? Okay. That's why the radius is d here. It is not pi d square by 4. Because if it was a green volume, it was pi d square by 4. Because radius is diameter by 2. No? Understood? This is the radius, which is d, and d here also, and this is the center line. So this is cylinder is occupied by the gas volume 1, right? Okay. Now it sweeps a volume of pi d square by pi d square v delta t. Okay. If n is the number of molecules per unit volume, if n is number of molecule per unit volume, ठीक है, the molecule suffers this molecule 1 suffers n pi d square delta v delta t collisions in time delta t. If n is the number of molecules per unit volume, n pi d square v delta t collisions in time delta t, it suffers one suffers right now. Just write it, I will explain it. Okay, it is saying that if n is the number of molecules per unit volume, then this molecule 1 suffers these many collisions in time delta t. So this is the rate of collision. The rate of collision kitna hai? Rate of collision is collision per unit time. Rate of collision is, you can divide it by delta time and you'll get this. This is the rate of collision. Collisions per unit time. And what is relaxation time? Relaxation time is 1 by rate of collision. So let's say if there are 5 collisions per unit time, then what is the relaxation time? It is 1 by 5. For if there are 5 collisions happening in 1 second, then for 0.2 seconds the molecule is not colliding with anything. So it is relaxation time is 1 by ROC. So it is 1 by n pi d square delta v. I have not understood this part, so I will explain you later what is the, if n is the number of molecules per unit volume, number 1 suffers this collisions in time delta t. Okay. Okay. So average. So this is relaxation time, and what is the mean free path? Mean free path. Oh, sorry. Mean free path is how much distance it covered without colliding. So the mean free path, which is equal to L, is equal to relaxation time is also called tau. Okay, it is your velocity into tau because distance is speed into time, right? And that will be equal to 1 by n pi d square. It is 1 by n pi d square. Okay, so this is your mean free path for formula. Okay. And sometimes the formula is also 1 by root 2 n pi d square. It is not in the syllabus, but the formula for L is this also and this also. Okay. Okay.
So in the second formula, where do we get root 2 from?
Out of syllabus. Out of syllabus. Okay. Okay. So I'm going to do some problems from this chapter. किसी का thermodynamics आ रहा है? किसी का thermodynamics आ रहा है? नहीं आ रहा? ठीक.